Okay, everyone. Rather a compact group this morning. It could be that some folks had too good a time last night. I'm not sure. It certainly was a gala evening, and those of you who were there, I hope you enjoyed yourselves. I suggest everybody move up, because the folks that are in the far back reaches of the room there, I mean, it's fine if you want to be there, but the speakers may feel like there's something they said that has pushed you away. Come on up, if you will. And I'm going to go see if I can get some people in from the back. Oh, here we go. From outside. I think we'll get underway. This is the last day, and we don't want to compromise the time that we spend in the technical session. So, the impact of 5G is the plenary this morning that's about to get underway. And then we'll have a brief coffee break, and then we have 2 technical sessions and then lunch. So you will recall the correction in the program. Both technical sessions occur before lunch, and lunch is scheduled to start at 1:30. Just remember that the technical sessions are back-to-back, and then lunch starts at 1:30. Mark, I'd invite you to bring your panel up, and we'll get underway. Thank you.
Jeffrey, thank you, and a good morning. So, impact of 5G. I was one time a navigator in the Air Force, and some of us had problems with dyslexia. So we had an aircraft called the CF-101, which was a 2-seater fighter aircraft. And what would happen is that those with dyslexia in the back would tell the pilot, hard port. And they get it mixed up, you see, and they would tense up the wrong way, and their head would bang off the canopy, and that would be the impact of 5G. And so it solved the dyslexia problem very quickly. Where's Sébastien? Come on up. My name is Mark Aruja. I'm the chairman of Unmanned Systems Canada, and I've got the pleasure of introducing a distinguished panel to you this morning on the subject of 5G, where G stands for generations, not gravity. Tomorrow morning, I'm going to be attending the official opening of an automated vehicles test site in Ottawa, a 1,500-acre property in downtown Ottawa, which has been fully instrumented in with the city's traffic management systems, a number of other technologies, including 4G and 5G dedicated test networks from Nokia. Ericsson is involved, Juniper Networks, and others. And the interest there is to see how we can take UAVs, or drones as we'll call them this morning, and use that network technology to actually control and manage those assets in what I believe ultimately will be the transformation of how we undertake air traffic management as we know it today. We will transition from ground-based radar infrastructure to a network-based infrastructure. Very excited to understand what 5G offers in that context, which is smart cities, if you will. So this morning, we have a great panelist. You've got the bios in front of you. I will ask the opening to be done by Sébastien Vaillancourt of Thales Research and Technology. He is going to introduce 5G, and then he's going to talk about a large collaborative R&D program called Encore, and introduce that program to you. Then Brunilde Sansò of Polytechnique Montréal will talk about some of the technical opportunities and challenges, and happen to be that she's going to talk about drones both using these 5G networks, but also potentially closing some of the gaps in providing network capacity and some of the issues with that. Then Christophe Bouchaud, Senior Vice President with Aviation Strategy International, and he's going to talk to us about a use case. And he's talking about the business case in an aviation context. And then I'll ask Sébastien to come back up and talk about some of the initiatives that Thales has underway. I believe they're all within the Encore program, perhaps more broadly, in terms of where some of the research activities underway within Thales in 5G. So without further ado, Sébastien.
Where's the presentation? This is a clicker, okay. OK. Bonjour tout le monde. Je vais essayer de vous I will try to present you Encore this morning, what it is. Encore, first, it's a unique 5G test bench. It's an initiative of 4 years. It's to help, we will see later, all the type of organization, academia, big company, SME, to develop device, equipment, service, and link with 5G. This will Encore help the company and everybody want to learn and to progress with the 5G and develop stuff with the technical support and the business support. It's also a project, we call to project with some kind of different subvention. But before to discuss about what is mostly Encore, what is 5G? 5G, the easy way is the next generation of cellular phone. What it will do, it will go faster. And every time we have a new generation, it's go faster. But it's way more than just go faster in 5G. The 5G, the faster part, is the easy part. It's an evolution. But 5G is a disruption technology that will bring other capacity than just speed. What is the other capacity? It's also the volume of data, but not just the volume of data. We need to see that in the number of devices can be connected at the same time on a on antenna. That will bring example, you go to a big event. When you go to a big event, a lot of people try to connect at the same time. You lose all capacity on your cell phone because everybody tries to connect. And 5G, you will be able to connect a lot more devices. Capability to connect a lot more devices, bring one thing. For Internet of Things will help to connect a lot more devices because today we install more and more Internet of Things. Now the 5G will give that. The other capability will be the consumption. If you use a lot less energy, the same battery that you install that will stay for 6 months today on your device will stay for 10 times longer. It means that you change only every 5 years now, not every 6 months. On maintenance costs, it makes a big difference. The latency change a lot. It's make that the time of response for all machine control, the time will be 10 times faster. Like if I send a comment, it will take 10 times less to receive on the device. That gives a chance to cloud controlling of machine. And of course, the deployment of speed that it's helped to because it's a lot more virtual equipment there. Why 5G? 5G, it's also because of a big impact on the economy and on a lot of different areas. Yes, we are here for talking about aerospace. Yes, it will help on that. You will certainly have hear about drone, will help for that. Will help also on what we call all transportation. It will help on manufacturing and so on and so on. Now, what is the economic impact? It's so dependent on what you include. Do you include that it will, because the 5G will help the artificial intelligence to bring the artificial intelligence to your device. It will help the Internet of Things. Do you include that in the bucket? It's depends what you include for the numbers, why the number is not there. 5G, it's today. You think that this will be on long term? It's not real. Today, you can see that it will start in 2020, and in 2025, it's around 34% of the population will be covered by 5G. Sounds not a high number? Today, it's around that number that you have for 4G around the world. Now, it's coming fast and will arrive relatively faster to the cover of the world for the 5G there. And on the other side, you see that in Encore that you have a lot of different test bench around the world. Yes, we have in Canada, we have Encore that is one of them, but we have other projects also through there with Bell or Nokia. They do the different test bench there. Why we are interested in 5G? First is to do better what we already do. It's not necessary to bring an application, it's just to do what we do better. To do what we are able to do on a test level in 3G and 4G. I will give you some kind of example. You're able to connect Internet of Things with 4G. I have a watch that is connected to 4G. It's working, but it will be better when I have a lot more device with the 5G, because first the consumption will be better. I will be able to connect a lot more devices in the same time. I will do the same kind of idea, but better. And of course, new application. New application will come with the capability of this new backbone. Lot of different things, a lot of different applications will come with the time that you can go in a media that where we will have a short-term interactive live event where we come from for 8K video or reality, virtual reality, augmented reality. You can go in transportation where you have real-time information to autonomous vehicle later, in manufacturing, float of management, and remote supervisor to really cloud computing and remote control, and so on and so on. It's an impact on all this kind of industry, a lot of use case that we will discuss more precise with this industry a little bit later. Encore, it's not just, it's an acronym. It's an evolution of network service through corridor in Quebec and Ontario for research and innovation. It's a program with 3 governments, Quebec, Ontario, federal government, and 5 multinational. Ericsson, that is in charge of all the wireless communication. Sienna, all the backbone that go through to there. IBM, it's really device component they do in the antenna. It's the Bromo plant. They work on this project. And CGI and Thales are there to develop what we will do with the 5G. CGI mostly in the smart grid, and Thales in the smart city. We have also other organists to work with us. What is the target of audience? It's technology company, non-technology company, startup, SME, big company, corporate, research. In reality, everybody except the common people. It's not to replace Bell, it's not to replace Roger, it's not to redo that. It's a test bench that we make disposable for everybody who want to develop. And when we talk about test bench, we have installed 5 antennas through 3 in Ontario, 2 in Quebec, for everybody who want to come to make tests with us and develop new device using 5G. Now, what we offer, it's a toolbox for the people. A toolbox that we can use over there that, yes, the antenna, but it's also a cloud software for developing networking, or to another cloud software that is used called IoT Accelerator that is offered by Ericsson for free if you come to the Encore program to develop and make your device over there. 4 different programs that they offer. One is a free access to everybody. Another one is for IT project, that if you develop a device, an equipment, or a service that you want to help of financing, we will reimburse 50% of your costs for project between around 100 and 200K, project around 9 months to 12 months project. Adoption project, it's more a group of people that will organize together to make a project with 5 SME. SME is for small, medium, and enterprise. It's a company to between 2 and 5 employees, 2 and 500, not 5, 500 employees, that they will develop together a use case. I will take a little bit your example. You want to develop a smart airport. A smart airport, you want to make a demonstration of the concept over there. You will have an airport company, an airport will come with 5 SME with different devices, and they will together build a project to show the capability there over there. That is part of the program there. And the last one is a collaboration R&D project. Each of the big 5 multinationals have an obligation in this program to develop equipment or develop things in orientation of what they do with SME over there, and that it's all the 3 first, you conserve all your IP. The last one, we share the IP with the big one based on the contract that you have. We have installed 5, like I always say, 5 hubs where you can make 1 in Waterloo, 1 in Toronto, 1 in Ottawa, and 2 in the province of Quebec. 1 is in Montreal at the Santec, where was the planetarium, and the other one is at Quebec City in Thales' office. It's also part of. I'm done with my small introduction and enjoy the rest of the presentation.
Okay, so in that case, I'm going to use this. Let me see how. Hello? Everybody hears me? No. Yeah, it's okay? Okay, so first of all, I would like to thank Denis, who's here, who invited me for this panel. I come from another world, and I realized making this presentation how different, even the jargon can be between the 2 worlds. I come from the networking community. So I'm going to talk about the utilization of drones to enhance the 5G network. So actually, how we are thinking of using drones to make 5G more interesting, more efficient, and more performant. So drones have 2 different roles in 5G. They are either considered user equipment. And the user equipment is, for instance, your telephone is a user equipment. Your laptop can be a user equipment. A sensor that transmits information into the system is a user equipment. The other role that we are thinking of, the people in telecommunications are thinking of for drones, is as infrastructure. So use actually the drone for infrastructure. And here we are talking about base stations, relays, backhaul systems, and flying networks, and even edge computing and caching elements inside the drones. And I'm going to explain a little bit more later when we get to the opportunities for drones. So before I get into the opportunities and the challenges that we have when we incorporate drones into the 5G, I'd like to give you a little bit of technical stuff about 5G. So what is this 5G about? I mean, how is it different? I mean, from the things that Sébastien said that we can do now, why we can do now those things with 5G that we couldn't do before. So the first thing, unfortunately, I don't think I have this doesn't have a pointer. Huh? No, okay. Well, I'm going to be here so that you can, I can at least see the little points here. Okay, thank you. The first thing is the millimeter waves. Okay, so the first element of 5G is millimeter waves, and this means that we are going to be in much higher frequencies. And this means that we are going to have very little propagation. So we have the coverage that we have in 5G is much shorter than what we have in traditional telecommunication networks, in traditional cellular networks. The second point is small cells and ultra-dense networks. So the fact that we're using millimeter waves makes the cells very small. Now, you may ask, why are we using then millimeter waves? Is because that is what gives us the increase in capacity. So we have an increase in frequency, and this increase in frequency gives us the increase in capacity. The third point is the notion of beamforming. So instead of having irradiation all over the place, in 5G we're going to have beams that can be directed towards the user equipment in a very efficient way, and can be actually very, very precise beams. And this is one of the things also that increase the capacity of the system. We have in fourth place the massive MIMOs. So what are the MIMOs? Are antenna arrays. MIMOs means multiple input, multiple outputs. So it's antenna arrays, and these antenna arrays increase also the capacity of the system. Next, we have two elements which are very important in 5G, the flexible core network and the network slicing. Flexible core network, we have these two notions are together. In 5G, we could have networks on the fly. So you can actually, you want to have a network and you have a slice of the network. So how this is done? This is done by making a partition of the elements of the network and giving that partition to two particular services. And this is, we are able to do that because of virtualization and cloud computing. So essentially, in the core, what we will have, instead of having equipment that is allocated to a particular function, we will have virtual machines that are allocated for particular functions and that we can change if needed. Next, we have cloud and edge computing. Of course, cloud computing is necessary for the flexible core network, but what is also interesting is the notion of edge computing. Why do we need that? What is edge computing? Edge computing is essentially, instead of doing the computations somewhere in the cloud, very far away, you try to do the computations very close from the demand. And in that way, you have a lower latency and you have more reliability. And the last point that I put is the type of applications that have been thought of for 5G. There are applications like device-to-device applications, like vehicle-to-vehicle applications, machines-to-machines applications. And the difference, for instance, in machine-to-machine application, they are not human. If you want to implement the smart cities, for instance, the IoT, the smart cities, you are going to have machines that have to communicate with other machines through the 5G infrastructure. And those applications in general have one key element, is that they are largely geographically distributed. Okay, so these are the main characteristics of 5G in technical terms. Now, what do drones, how come drones are interesting for those features? Well, first of all, they are flexible. They can go up and down. They can move. Okay? So this is very interesting for us. If you have, for instance, you have small cells, you will have to be doing handover from one cell to the other. If you had a drone that follows the mobility of the application, you don't need to do that handover. So the mobility, the flexibility, the number of drones that you can change on the fly, the number of drones. And I'm going to explain to you a little bit later about the antennas, how we can take advantage of that. And in general, it's the 3D nature of drones and also the cost. Because if we replace expensive infrastructure by drones, we are going to lower the cost. So let's start with the opportunities that we have if we want to have drones in 5G. The first is the increased coverage and capacity. And I'm just going to explain here that coverage and capacity are two different things. Coverage is what gives you the opportunity to get into the system. So you need coverage. But with just coverage, you don't have access to the system. In order to have access to the system, you need capacity. And the capacity is, for instance, the time slots that the system is giving you, or the channel frequencies that the system is giving you. This is in terms of capacity. So capacity is more related to the protocols, and coverage is more related to the electromagnetic propagation. So drones gives us an opportunity in both coverage and capacity for the rural areas, of course, because you can cover rural areas that are not in the system right now, and also to increase the capacity of those rural areas. Of course, emergency systems. If you have elements that go down You can replace them with drones. Special events. At the moment when you have special events, for instance, you have the Super Bowl, the service providers are going to have cells, special cells that are transported to the Super Bowl in order to provide the capacity that is needed. Instead of having those mobile cells, we could have drones instead. Improve the reliability of device-to-device, vehicle-to-vehicle, or machine-to-machine applications. Why? Is because, for instance, if you have device-to-device, you are supposed to, from one device, send the information to another device, and the information to the other device up to the infrastructure. If you could have drones that immediately can pass the information up to the infrastructure, then you can improve the reliability and the capacity of the system. And finally, the notion of offloading traffic. So offloading is a little bit what happens when you have your telephone and you go from LTE to Wi-Fi. In the end, what you're doing is you are offloading your traffic into your Wi-Fi network. So the drones could be thought of elements for offloading traffic when there is too much congestion on the normal system. Second point, second opportunities is enhanced ground communications. Well, one thing that we could do with drones, since we are talking about vehicle-to-vehicle applications, drones can move and can see what is happening. So that information could be an interesting information for safety of the vehicle-to-vehicle communication. Provide key information in types of energy. A drone can actually be a communication node in case of emergencies. And finally, it could act also as a gateway, for instance, toward the internet for clustered users. Another opportunity is in maritime communications. There is something that is called ducting, and ducting is due to the difference in the refractive indexes that we have in the atmosphere. So the ducting is essentially a tunnel, a communication tunnel, that can go beyond line of sight. The problem with ducting is that it's difficult to tune the ducting. So the drone actually what does is that you can go up and down and tune the ducting and improve the maritime communications. Now, we get into the antennas. There is something that is called, there is MIMOs and there is 3D MIMOs. So 3D MIMOs, essentially what it is that we are going to put more antennas in all dimensions to increase the capacity. Now, if we put those 3D MIMOs into drones, then we can have more, because of the zooming opportunity that drones gives, then we can have a more effective beam forming. So we can increase the capacity of the system as well. Next, people are thinking of antenna drones, actually antenna drones. So you have your drone is your antenna. And since you can have several drones that can be put together in different ways, then you have reconfigurable antennas that can also fly. So depending on what is the state of the system, well, you could fly those antennas and improve also the capacity of your system. Another opportunity is to improve IoT communications. Why? Is because the drones can be on one hand, it can be closer to the application, so be used as relay to more quickly send the information. And the other thing is that when you have small elements in the system, these small elements there are, a bunch, thousands of elements that are going to try to get into the network. These small elements have energy constraints. So the more you try to get into the network, the more you reduce the energy that you have available. In that case, the drones could be used to reduce the energy consumption of those elements. Other opportunities. Well, the first one is what I talked to you about, the handover. In 5G, we probably will have a lot of handovers because the cells are smaller. So if we could use the drones to follow a base station drone to follow a mobile application, then we reduce the number of handovers, definitely. And we have fewer problems in the system because handovers, they are not nice. You need special algorithms to do effective handovers and things like that. Next is using drones for caching. And the idea is that you will have mobile applications, and those mobile applications imply having certain information at particular places where you move. So you could learn what is that information and put that information into the drone, instead of having that information cached in particular servers in the system. Finally, on this part, the on-the-fly edge computing. For instance, in the case of smart cities, you need to make some calculations very quickly instead of sending them to the cloud. You could use the drones for that. Another important point for drones is the backhauling. So I don't know if you people are aware of what backhaul is in this. Okay, no. So the backhaul, essentially what you have in a cellular network, you first have the access, which is the part from your telephone to the base station, to where the antennas are. And then all the antennas have to communicate to the core network. So where the routers are, and eventually you get into the internet. Now, in 5G, we are going to have a lot of cells. And each cell should be connected to the core network. This is what we call the backhaul. So they are thinking, they say, okay, we are going to do a backhaul of fiber networks. But that is extremely expensive. Another way is to multiplex lines for the backhaul, but then you can create a congestion problem. So the idea of having an aerial backhaul of drones is making, people are thinking about it to reduce the cost of the backhaul, to reduce the backhaul congestion, and also because it's going to be a backhaul that is dynamic. And don't forget that one of the problems that we have with the 5G, with the millimeter waves, is that they are also very prone to, you cannot have obstacles. So the moment you have obstacles, you don't have the communication. So the fact of having something that is dynamic is very interesting. So you may say, well, this is wonderful. Why don't we have thousands of drones going around for the 5G? Okay, we have a lot of challenges. So the first technical challenge is the channel modeling. So what is channel modeling? We need, when we are doing planning for systems, or planning or operational planning, or physical planning, we need to have equations to be able to know the propagation that we are going to have and the characteristics of that propagation. And because of the high frequencies in millimeter waves, there is just no formal channel modeling for millimeter waves. I mean, it's amazing, but it's the case. So that's one of the problems, just with millimeter waves. If you add to that the fact that drones are going to go up and down, that's even more challenging. They are telling me to speed up, so I'm going to do that. Next thing is performance modeling. Of course, you have to integrate so many things, and you have to integrate at the same time the 3D nature of drones that we need more effective models for that. The deployment of drones, of course, is also very challenging. And just the way to find the right trajectory for the drone in that kind of system creates a problem. The final point I would like to mention is the 5G slicing and the drones. So the slicing is, as I told you before, I'm going to give you a part of the network that is just for one type of service. For instance, Google could have one slice, and the slice is just Google network. It's like they had the whole network for them. Now, the problem is that the slicing architecture was thought of with the service in mind. Drones as infrastructure, supposedly they can serve different types of applications, not just one type of service. So we cannot have as many slices as drones in the system, and this is something that has not been solved yet. I mean, marrying the notion of drones with the notion of slicing. Well, as a conclusion, the 3D and the mobility nature of drones gives us great opportunities to enhance 5G networks, but they also produce challenges because of the large scale planning and implementation and issues, and those issues are at all layers. I mean, from the physical layer up to the application layer. Thank you.
Hello. Bonjour, good morning. So we'll go now after, thank you Brunilde for very, very good introduction to the technologies and the different advantages. What do you do with all of this is the question we have, especially in regard to airports, and that's going to be the subject for what we're going to be looking at now. Airports, as Mark was saying earlier, are really cities. They're very, very complex environments. And they face a lot of challenges, and 5G brings a huge opportunity that is unparalleled with anything that we've seen before that. Everything that I'm going to be talking about is actually part or extracted from a couple of publications that ASI has put out, the most recent one being our Megatrends book. So if you're interested in digging a bit more deeply into the different subjects, then you're more than welcome to see me at the end, and I can steer you to those publications. So I'll give you a little bit of a crash course, pardon the pun, on airports. And if you are an airport manager today, you have a huge challenge. And the first one, which is a good problem, is growth. And year in, year out, as you can see on this graph, airports and air traffic, civil aviation traffic, has grown by 5% for 100 years. 100 years. And there is no sign of that actually slowing down. Most of my work is done in Asia. It's just stunning. Just going back to airports every 2 or 3 months, you already see the changes. It's absolutely enormous. And growth management is their #1 issue. So the solutions to that are quite simple. You need more land, and airports are expanding all the time. And you need more equipment because you have more planes coming in, you have more cargo, and so on and so forth. Those solutions have limitations because there is simply not more land. More people are annoyed, to say the least, or put it mildly, about airports constantly encroaching, and we have to build them further and further away from the city, which makes it very, very complicated. The second problem that you're going to be facing is safety. I want you to be reassured. It is the safest mode of transport, bar none. And it's been done and achieved through regulation. And you know that Montreal is actually the capital of the aviation industry worldwide because we have ICAO, we have IATA, we have ACI. We have pretty much all of the worldwide governing bodies right here in Montreal. It's also been achieved through more inspections, and it's also been achieved through more compliance. So every time there is an incident, new regulations come out, and the industry becomes safer and safer and safer. However, as an operator, that means that you have to expend a lot of time and money and resources to comply with all of these regulations and to have all of the manpower, quite simply put, to do these inspections day in and day out. The next item that you're going to be running into is this regulation is concentrated, I would say, 90% of the time at the airport. And just to illustrate this, excuse me, just to illustrate this, this graph sort of shows you where most of the incidents actually occur. And you will see that they are at or near the airport. So the regulators, quite logically, have concentrated on regulating the most dangerous or risky areas, and they're pretty much all in the airport. Now let's look at the business case. These data are from ACI, which is the Airport Council International, that represent pretty much all airports around the world. There are roughly, in this particular statistical base, about 6,000 airports around the world with significant traffic. And you will see from this graph that the airports that we're familiar with are usually the big ones. So Montreal is a medium-sized airport. Those airports actually make money. However, 93% of airports around the world do not make money. They are money-losing propositions. And it's a structural issue. Whether you have one flight a day or whether you have 100 flights a day, you're still going to have a runway that's roughly 2.5 to 3 kilometers long. You're going to have to comply with the exact same regulation, regardless of the amount of flights that you have. You're going to have the exact same type of infrastructure. You have to have a control tower. You have to have a firefighting team. You're going to have to comply with all of these things, even though on the revenue side, you only have one flight compared to hundreds or thousands or tens of thousands. And that's why most of the airports lose money. So these airports are not going to be shut down because they are actually needed. There are communities, and I mean in Canada we're very well placed to know this, up north, where the only lifeline is the airport, the only ways of communication. But more and more, governments are not willing to shoulder those costs. And of course, I don't need to tell you, it's not a big secret, airports are being privatized, left, right, and center all around the world. And this gives you a little bit of a snapshot as to what's happened in 6 years and how fast that privatization is moving ahead. Now, you can imagine that the companies that are moving in to run these airports are not very happy with the notion of, well, 93% are losing money. So what do you do about that? Last challenge as an airport manager, facilitation. Now, facilitation is the notion of making your journey pleasant and easy. And I just challenge you to tell me which journey you took in an airport. In the last few years, I can hear a few laughs already. In the last few years, if not months, that's been either of those descriptives. None. Now, it's not really the airport's fault in the sense that they're mostly at capacity. The systems that they're using are extremely complex, and there's tremendous pressure. Yet at the same time, the backbone that is being used, the communications means that are being used, are very, very disparate and disjointed. And that is a huge issue if you're running an airport. Now, let's take Dorval here in Montreal as an example, Pierre Boucher. There's roughly 20,000 people working at the airport. However, the airport authority itself has 1,800 employees. But they are responsible for 100% of what occurs there. So now imagine running a city. Well, if you're running a city and you're the mayor, well, the police force, those are your employees. Firefighters, those are your employees. You control, as a mayor of the city, you control most of the means to deliver the services to your citizens. If you're an airport director, you control, if you're lucky, 10% of the means. And that's your big challenge. And you're facing all of the problems and challenges that I exposed before. Therefore, facilitation, which should be their #1 mission, which is to make you, the passenger, happy, is very, very difficult to implement. By the way, it's an ICAO regulation, and there are standards for facilitation around the world. So how are airports responding to this? Well, essentially, they are moving with, I'd say, very late into the game. They are moving to do exactly what other industries like telecommunications, security, and so on and so forth have already done. So the very first move, and I'll explain this little complicated graph here on the bottom, is operational focus. And to do this, they've implemented what are called AODBs, or Airport Operations Databases. Now, this is very, very basic. This is just getting all of the data that they need to run the airport together in one database. So that means communicating with the airlines to know, well, when are your flights? What's your flight number? When does it depart? What's the capacity of that flight, and so on and so forth. Believe it or not, half the airports around the world compile that data through telex. No laughing, please. A lot of the airlines still communicate via telex. So they send these paper lists that are then inputted manually. Okay? Half of the airports do this in Canada. Never mind other countries. We're not talking about Africa here, right? I don't even want to tell you what it looks like out there. So this notion of AODB, roughly 50% of airports around the world have one. That means 50% of the other airports are still being run on a paper basis, or maybe some Excel spreadsheet. Next stage after that is what's called an AOCC, or Airport Operations Control Center. And that's a very simple notion. You put all of the equipment in one room, and you have all of the people who manage operations at the airport itself, air navigation, airlines, ground handlers, maintenance companies, et cetera, in one room so that they all share the same information so that they can actually handle operations. Okay? Well, when we get to that stage, roughly 25% of airports around the world have an AOCC. If I look at the telecommunications industry, that number is 100%. If I look at any utility company, that number is 100%. Okay? And those are just for day-to-day management. Now imagine that there is adverse weather. Imagine that there is a big hurricane or typhoon or snowstorm coming in. Okay? None of these entities are actually capable of projecting forward. So they're not able to actually plan for and simulate how you're going to deal with a disruption in your operations. So surprise, surprise, when we have a snowstorm, hey, we live in Canada, we have those all the time, right? There are huge delays. Why is that? Because very few airports actually practice for that because they're so busy just running the day-to-day. And most of them are at capacity on a constant basis. So there's very little slack, very little capacity left over to actually deal with the situation, and more importantly, get back to normal operations or business continuity. Okay, so that's why it takes a week, 2 weeks, even 3 weeks in the case of Heathrow about 6 years ago to recover from a snowstorm. Okay, even though these are things that occur and will occur more frequently as a result of climate change, and we've already seen this. We have put out a white paper, we've been working on it with a dozen airports around the world, to put a new standard in which we call the AEMC, the Airport Enterprise Management Center, which is going to do exactly what most large utility and service companies already have today. Okay. That concept, AEMCs around the world today, there's probably 1 or 2. Okay. And it's not because the airports don't want to do it, it's just that it's so complex because the community that you are dealing with is so disparate and has so many ramifications that it's difficult to unify all of these people. That doesn't mean we shouldn't try, we have to do. And the reason we have to do that is because growth is simply not going to continue based on the business model that we have today. There is simply no more land. You cannot put more equipment. You have to start automating. You have to start exchanging data using artificial intelligence to sweat the equity, to use the equipment much more efficiently than what we are doing now. So where does 5G come in there? Well, the airports have obviously tried to do this for a number of years, but there was no technology that would allow them to get everybody on side. There are thousands of kilometers of black fiber at airports. Airports have tried to convince, let's say, airlines and so on and so forth to connect to those fiber and to use a single network so that they could exchange data. Most of the operations, especially during an emergency, still use VHF radio. If your flight is delayed and there's a gate change, that information is actually all voice. It's the airline talking to the operations center at the airport, and somebody saying to each other, well, you should go to gate 5G as opposed to gate 5F, right? So that's not very efficient, and the more complex it gets, the more difficult it's going to get. Okay? So the business case for automation is not one that needs to be made. It's the difficulties in the implementation. Remember when you came back from your last international flight? How much time did you spend in the lineup? Well, guess what? Customs and immigrations typically do not speak to the rest of the airport because they're a separate entity. The people at the security inspections, excuse me, at the security inspections don't talk to the rest of the airport either. They're on a different bandwidth. They're even on a different band as far as their communications are concerned. And because their cameras are, well, secret, they don't share them with anybody else. So the airport is essentially blind. What does 5G bring to the party? Well, as Brunilde said very, very well, and as Sébastien was exposing before, we get a service level and a quality and availability that did not exist before. If you're an airport and you're managing an emergency, you have to have 5 nines or 6 nines availability on your network, because the second there's an airport, there's a crash or some incident, you're going to be able, you have to be able to take that telephone and start talking to your emergency crews. Okay? It has to be 100% reliable. You cannot do that using existing wireless technologies. That's why they still use walkie-talkies. Okay? Slicing. That was a quick point made by Brunilde, but slicing is actually the most important thing about 5G, which is not available in current technologies. And the notion is very simple. Today, if I'm bringing in, let's say, I'll share a little secret with you. If there's a fire in a terminal, there's a firefighting team at the airport, right? Those guys will not intervene to put out a fire at the terminal. They're not equipped to do that. The firefighting team at the airport is equipped 100% to put out a fire on an aircraft. So they are not capable of handling fire at a terminal. So if that happens, they're going to have to call in the firefighters from the local municipality. Those guys have, well, radios. Guess what? They're not compatible with the ones at the airport. So now I'm the airport emergency manager. I'm trying to coordinate these firefighters coming in from the outside. I have to tell the people at the gate to let them in, right? And I have to tell the firefighters where they have to go. And we're using 2 completely different, incompatible systems. Okay? So now you're starting to understand the pain of how I have to manage all these things. And this is just one simple case. In the case of slicing, what we can then do is essentially provide all of the stakeholders, external, internal, and so on, with a bring your own device type of policy in which we can simply put an app on there that they can share. But obviously, Air Canada does not want to share any data with its arch rival WestJet. So where the slicing comes in is that you can separate now all of these virtual bands, if you will, so that you have one shared one for everyone in case of emergency or operations, but still have the wherewithal to handle your internal operations in a safe, efficient, and secure manner. I'll go even further than that, and pardon the pun, it's slicing the slice. where airports have actually put in some networks on fiber and so on and so forth, sliced it and then realized that it's even more complex. The different stakeholders want even more complexity behind that. 5G provides all of those. Low latency. That sounds like, well, you know, well, so what? Well, IoT is coming. More and more of the operations, I mean, if you land here at Dorval, and nothing, you know, no criticism of the airport, but the bridges are all manually operated. Half the time, if you arrive early, there's nobody at the bridge to actually manage it. And you're waiting there, and typically, and I do a lot of flying, if I come in 20, 30 minutes ahead of schedule, typically I will be late getting into the terminal. That's because there's simply not the capacity, human resources, to man all of these bridges and to come in early to actually manage that bridge. That is the first thing that's going to be automated. But we need to get those operations and the data and the control back into the AOCC, into the control center. And that will not happen through the existing networks. And the reason it hasn't happened up to now is because of latency, right? It just simply took too much time for the signals to come back and forth to have a reliable, remotely controlled gate. Never mind baggage carts, which are going to be next. Never mind all of the operations that happen around the aircraft as it turns around, okay? Yep, pretty much done. Multiple connectivity, IoT, bandwidth. I don't need to make the use case for that. There's a lot of bandwidth that's required at the airport. And obviously, security. Airports are very insecure and are very, very, how shall I put this, vulnerable right now because of the sheer volume of different and disparate systems. When you're connecting a ODB, typically, in a medium airport, 5 to 10 million passengers, you're going to have something like 60 to 70 different connections using different platforms, different software, different levels of security, and so on and so forth. Very, very vulnerable to attacks. So again, unifying all of those onto a single backbone will bring about cybersecurity to the airport realm. And obviously, airports are very attractive targets, and we've already seen this. So, the main difficulty of all of this is not so much the technology, it's available. The main difficulty is going to be the business model that's going to be behind this. And there's a couple of ideas that I've put here that the industry will be moving towards, but there is no set recipe right now because it's going to go against a lot of the existing business models that we see today. The airport as a micro-operator would be simply them handling or using the equipment and paying for it, which is going to be rather difficult. And we're probably going to be moving towards some hybrid kind of model in the future to make this work. Thank you. Sébastien?
Hi again, everyone. I will talk about a use case that we call the connected officer that we develop or we study proof of concept with Thales. Now, I want to return to a little bit of the notion of what is 5G and to explain you where it's going on with our connected officer. Now, yes, we have the data transmission data. You will see we will talk about high-quality video and so on, where we need that. The low latency is particularly critical for control and so on there. Now, I want you to keep this kind of capability that will have the 5G. We have discussed I didn't discuss that slide more early, but all my partners discussed about the slicing. And the slicing, it's true, it's a very critical capability that will be in the 5G. It's a quality of service from network to network, that it can pass through different operators. You can have a quality of service depending on the slice that you are. Yes, it's good for security privacy, but it's also good to be sure that the service arrives at the time. I will take an easy for smart city. If I use 5G to control my autonomous car, and I use the 5G to send a Facebook picture, personally, I want to be sure that my car brake at there. I have no problem that my Facebook picture takes 10 seconds later to be on Facebook. But my car, if it takes 10 seconds longer to brake, it's a big issue. Now, some service need to have the quality there. And on a first respondent, it's very critical because you need a communication at the time there, and it's why you talk about an airport people, but it's true for officer, it's true for firemen. They have all their own communication system because when happen an event, what do everybody? They jump on their cell phone to tweet, to call a friend, to do something. What make that? It's jam-packed, you have no bandwidth, and this kind of people need a communication there. With a slicing, they can do that. They can use the standard operation and certainly to have a communication because they will have a quality service guarantee on their slicing. What is the connector officer? The connector officer, it's a lot of different devices that is connect on an officer. The first is the camera. The camera that when we're talking about high data, if you want a high quality camera, a 4K camera on multiple of officers that you send all the data to the data center where you can make an analysis of the video, but not just one camera at a time, but with a triangulation of different cameras there to repositioning people. This kind of analysis is it's simple. If you see someone in the field with your camera, 10 minutes later, you will not remember that person. If I see a bald guy with a beard pass through there, if you're an officer and you look for there, you will see it. But if it was 10 minutes ago, you will not remember because you were not taking attention. But the camera can replace that in the time during intervention. You can have vital sign. That is an IoT device that you can have the heart, the respiration, if your officer is tired, what is his information. Of course, your localization, smartwatch, all this kind of data go there. And you can have smart glasses for augmented reality to give you an information about, hey, you want to make sure your officer or your group of officers in the field, what was happening 5 minutes ago or 10 minutes ago, that it can replace or re-see that in its face with different glasses. But on glasses on augmented reality, you have high-frame data, because if you're not, you have some kind of seasickness about that. You have a 360 view there, and you need a very high quality because it's directly on your face, so you will see all different pixels. For that, it's why you need a very high bandwidth there. It's why 5G will help in enabling this kind of functionality. Now, all of this data is through a control center that I will come back a little bit about that a little bit later. We use also, during an intervention, yes, we have the officer, but we can also use drone. But drone, not one drone, a fleet of drones. And why 5G will help that? First, for the slicing, you have the control to be sure that your control of your drone is there, that if you have an event and you have millions of people around there in the same time, you have your communication. The data you transport there, your 5G camera or other information. The low latency will help to control your drone because the time of reaction, if you change your flight pattern and so on, the fact that you have low latency help every machine control. The communication machine to machine that was discussed more early, that will help to have different, not just one drone, but a group of drones. They communicate to each other without passing to the infrastructure over there. Now you can have a group of drones that they can fly at a constant distance and have a very fast communication to each other and know where they are to each other all the time there. It's why 5G will help that. All this data, in our use case, it's transferred to what we have called a monitoring or a research table where you can see what the camera over there, pushing all your officers there, have all this vital signal of your different officer or different people. It's in the field there, and pass comment to them to say, okay, this group, you go at this place, you go at this place, to improve your intervention over there. This is plus or minus what we have called sensor hub platform. It's a prototype that we have done. We really have the table that is over there that you can see that the end over there to control and see what can happen in real life. I want to return. This was a little bit my use case that I want to present with you this morning. I want to return to a little bit of Encore because I have different art in my life, and one of them is to manage the hub site of Quebec City that we are in charge for everybody. Now, if you're interested and you think that you have an idea about what you can do on a 5G, or you want to do a project or investigate about that, I suggest you go to Encore website. You have a chance to inscribe and request your demand to have an access to make a test. What we want to do with you, it's just what you will do to be sure that we have the capability to make you do. We don't make a judgment of what is the value of the technology, what is there. We just make a value. Do we are able to make that test and the facility that we offer you to do that? Good afternoon.
That was great. So we have a few minutes left here. We will try to end at 10. I'd like to open up the floor to any questions. If you please use the microphones and just open up with saying who you are and who you represent. I'd like to open up the floor.
Good morning. So I'm Philippe Novelli from AERO in France. So everything you presented was very nice for someone like me who does not know anything about this. We see that in some cases it answers to some actual problems we already have, such as the one you described for the airports. In other cases, it's new services, it's increase. And as one of you mentioned climate change, and as I am dealing with environmental impact in my main responsibilities, I would like to ask you whether there has been a kind of global life cycle assessment of these new systems, because I understand that there will be multiplication of systems. You mentioned possibility of drones, so all of this need energy, needs resources, and we know that we have climate change. We know that we have currently a big deal with biodiversity, that we are going very far in using the natural resources. So is there any life cycle assessment of these technologies? Thank you.
We did speak about that in the book that I was mentioning on megatrends. What's very clear for airports is right now, since most of the technology that is being used is pretty much analog, for want of a better word, there is a tremendous amount of waste that occurs because if you look at ground handling, for instance, when an aircraft comes in and it's at the apron, which is when it's parked at the gate, typically, you will have 30 to 45 minutes for that airplane to turn around. Now, the ground handlers are private entities, and the way in which they coordinate the different equipment going around, and they only have half an hour, really, to make all of that happen, is extremely inefficient. By automating all of that process, right now, we know that roughly 30 to 35% of the CO2 emissions at the airport are due to ground handling equipment. And we know that by automating that completely, so using automated vehicles, thanks to low latency that's enabled by 5G, we will be able to reduce the CO2 imprint of the airport by somewhere about 25 to 30% through better and more efficient use of the machinery, number one. And number two, remember that all these companies, the ground handlers are all private. So they will change contracts on a yearly basis, sometimes twice yearly basis, which means that if you have, and I'll just mention a couple of names here, Swissport or Donata or Menzies or any of those big ones, you will have 2 and 3 and 4 times the equipment, the same exact equipment at the airport. So if Menzies get the contract this year, then the equipment that Swissport is using for other contracts is also being used. So in essence, you've got 3 or 4 times the same equipment being used, and of course, emitting CO2 and all the nasty gases that we know about, and essentially duplicating, triplicating, quadruplicating, if there's such a word, the amount of greenhouse gases that are emitted. So one of the models that airports are trying to get to is what's called common use equipment. The problem with that, of course, is that because these companies are competing for the services, they don't take care of the equipment, right? So they say, well, if I'm going to lose the contract, well, I don't really, I'm being a bit facetious here, but they're not going to take good care of it. So there's no good solution right now for that common use platform that you see. Now, as a passenger, you will see it, because now if you go to the airport, you'll see that it used to be that you had to go to the individual kiosk of an airline, and that would be dedicated to, say, Air Canada or United or whomever. Now you have the kiosk, and those kiosks, their computers, those are what are called CUTE, and they're completely common use. They don't belong to the airline, they belong to the airport. So that's one model that we know is going to work, but it doesn't work for ground handling equipment because of the reasons that I just mentioned.
Okay, with respect to the infrastructure, in people like myself, in my group, we are very much aware of the impact of the infrastructure, both the access and the data center infrastructure in energy consumption and CO2 emissions and so on. So one of the things we're thinking about is, well, we are more than thinking about, we have students that do PhDs and masters and so on those areas, is adding actually solar energy to 5G. I mean, having the new 5G base stations that can work with solar energy. That's one of the points. The other thing is how you manage the network so that you can reduce the energy consumption of data centers, which is huge. Right now, for instance, we know that just for data centers, if all data centers were put together, they would be, the consumption is equivalent of a country as big as Japan. I mean, it's something that is very, very large. So we are using also methods to reduce the consumption of data centers. And finally, one thing that bothers me in particular is the proliferation of IoT and smart cities. I work on smart cities, is the elements, all the elements that have to have energy, that have to be energized with batteries, and that's a problem. So we are looking at ways of planning the system to reduce the use of batteries, and also to take energy from the ambience. So this is what we are doing.
Did that help? We're looking at the light. Are there any other questions? Great.
I'm Sébastien Fit. I'm an engineering specialist in aerospace working for Airbus. So basically, the airspace is limited. The aerospace company wants to use it for urban mobility. 5G companies obviously want to use it as drone antennas. Also, people also have drones for their own usage. And I wonder if you started discussion with Transport Canada or the authorities to determine how the airspace will be shared, because it looks like more and more people want to use this space. And to me, it really looks like it will be the chaos in a couple of years. So just want to know if you started discussion about that.
Yeah, great question. I'll take the liberty of speaking to that because that's part of the world I live in. For background, Unmanned Systems Canada is an association that represents the unmanned systems industry, and we co-chair the regulatory working group with Transport Canada, have done so since 2010. So the question is, with regard to airspace management, the use of these technologies, where are we the regulator? So unmanned traffic management as a concept is probably about 6 or 7 years old at the most. And there are many initiatives going on in the world today. Singapore, a number of countries in Europe, which are on the path to implementing this technology. In Canada, we had policy conversations with Transport Canada last year, and as of January, there is a formal working group now, co-chaired by NAV Canada and Transport Canada, involves industry, and we're developing a national roadmap which will be hopefully ready by the end of this year, which will start to shape how this technology can be used as one step towards the larger process of integrating these unmanned aerial assets with the airspace that we have today. Clearly today, there's lots of UAV operations going on a daily basis, but this will be a stepped integration, particularly in the low altitude airspace. So the conversations are now at the formal collaboration stage with industry and the regulators. The other panelists don't want to weigh in. Is there any other? Did that help? Okay. Any other questions? I'd like to pose one to Christophe. So we get this 5G technology. It's going to make the airport experience a wow factor. Whisk through security, passport done, bag drop, we're in. And now we get on the airplane. Are the airlines looking at this technology, and what is their perspective of improving the passenger experience after you've left the airport?
Well, passenger experience, first of all, is mandated by ICAO. So that's what's called facilitation. Believe it or not, there is a 30-minute maximum waiting time for immigration. Wow, I know. 99% non-compliance on that one worldwide. They do surveys every year. Now, all kidding aside, the airlines are in a very, very difficult position, and they have sort of two broad answers to your question. Of course, they care about us as passengers. And what's happening is that there is an ever greater sort of atomization of the market. And you'll see it in the ads that they target at you, the consumer. And the world is pretty much divided between business passengers who generate about 60, 70% of the profits, even though they are about 5 to 10% of the passengers. So obviously they're going to pamper those, but rates are outrageous. That's not where the growth is coming from. The growth is actually coming from the leisure passengers. And those are now sort of subdivided into, you've seen the ads for, the basic fare. Those basic fares, the airlines are essentially saying, I don't care, I'm going to handle you like cattle, essentially. Sorry for being so blunt, but that's what you're paying for, what you're going to be getting. However, they also know that there's about 20 to 30% and increasing of passengers who are looking for a better experience, and those are the ones that are really growing. And the difficulty in providing a pleasant experience is that on board, the airlines can control, what you see, what you get, what you eat, your entertainment, and so on and so forth. However, most of your experience is going to be based on the whole process from end to end. If you look at, and there's lots of statistics, I would encourage you to go to the SITA website, which is sita.org, and look, or AERO, sorry, A-E-R-O, and you will see that they conduct regular reports that they put out every year, which are very, very good. And within those, you will see, for instance, that they are trying to look at the whole experience from the moment that you actually buy your ticket. Right now, we are over 50% of passengers actually book their own airline tickets from home. Okay, and the rest of it, it's 93% of people actually buy them in one way or another online. It's not good news, obviously, for travel agents, but it is good news in terms of customer satisfaction, because that aspect of the travel experience is actually very, very high. When you get to the airport itself, there is a very interesting stat that shows the experience that people have and the stress level that they have. And no surprise, the highest stress level is experienced by people first coming to the counter and dropping off their bags. That's when they start getting stressed. But the biggest stress point, of course, is presenting your passport and going through security. Now, if you look at the level of automation that's behind that, right? The higher the automation, the higher the level of satisfaction, the lower the stress. Surprise, surprise. People would much rather deal with a kiosk, which is why now you see these ubiquitous kiosks everywhere to get your boarding pass, and they are satisfied with those. The least amount of automation is actually in security and passports. And what we've seen is Europe is much more advanced than we are in terms of border control, and you will see that most of the borders you cross over there, they're going to be automated kiosks. You no longer see a human. Right? So you will present your passport, your biometrics will be in there, it will recognize you, you step into this little booth, it will take your picture, and then it'll let you go through. 90% of the time when I travel through Europe, I don't get to see a human. Guess what? Stress levels way down, customer satisfaction way up, and the processing happens a lot faster. But this only happens because the European Union actually forced the different entities, customs, immigration, sanitation, airlines, and so on and so forth, to share the data. The reason it's not happening in North America is because we're completely disjointed. And again, that's because we don't share data, because we don't have common networks, we don't have a common sort of regulatory framework on top of us, and it makes for a very, very inefficient process. And I won't even get you started on security or your last experience going through a security line, because that's the least automated process. And it's going to be very, very difficult to automate that for obvious reasons, but there are solutions out there.
Well, thank you very much. So there's hope for all of us. We're now at 10 o'clock. So hopefully this gave you some insights into what is 5G, what we've got to look forward to in the very near future, 34% market penetration within 5 years, some of the opportunities that are out there. And just to close on that, Christophe, I came back from an overseas flight a few weeks ago in Ottawa, automated process with biometrics in my passport. There were a total of 3 customs officials in the entire building. It was seamless. And you're right, and then I waited 20 minutes for my bag. But it was a very stress-free return back to Canada. So thank you to all the panelists here. And if you've got an idea, you're looking for some collaboration, a funding opportunity, Sébastien, it would be great to talk to you further about the opportunities Encore provides.
Thanks, folks. You're excused. Thank you so much, Marc, for your chairing, and Brunilde and Sébastien, Christophe. Merci beaucoup for a very fascinating panel. So the coffee is outside, 2 technical sessions, and then lunch back in here. Thank you very much. Enjoy the rest of your morning.